So let's look at a couple more examples of rewriting these exponential expressions. So for this one, what is the value of a when we rewrite 1.44 raised to the minus 1.2 times x? And we need to rewrite this as a to the x power. And figuring out what a is a little bit tricky here, but notice we have a product in our exponent. So when we take an exponent, let's say x, and actually let me use a different letter here, let's say y, and we raise it to the a power and then raise that to the b power, an exponent to an exponent, we will just multiply those together. So we're essentially starting with the right-hand side where we have a product, and we can work backwards to essentially get that x separated from the minus 1.2. So to do that, let's rewrite our expression. So this 1.44 raised to the minus 1.2 times x. We want x to be our outermost exponent here. So we can rewrite this as 1.44 raised to the minus 1.2, and then all of that can be raised to the x power. Since notice, we can just check this by reusing this rule here. So we have an exponent raised to an exponent, so they multiply to give us this original expression here. And since we have some expression raised to the x power, and that's essentially what we're going for here, this right here is our a value. So a is 1.44 raised to the minus 1.2 power. Since if we raise all of this to the x, we would get back our original expression here. So let's now look at our multiple choice and see if we can figure out the correct answer. So 1.44 raised to the minus 1.2. That looks to be choice letter D. So let's do one more. And this last one is a bit challenging. Some of these problems for rewriting these expressions can be a little bit awkward, but it is good practice being able to rewrite them in various ways since the different forms can be useful in different scenarios. So for this one, find the value of a that makes the following equation true for all values of x. So let me just rewrite it. We have 1/7 raised to the x, and this is equal to a to the minus 9x. Now, there are two approaches to this. Since this is multiple choice, we could just check different values of a and plug them in to see which one of them would simplify to 1/7 to the x. Or we can think it through a different way, since you won't always have multiple choice. So what we can start by noticing is that on the right-hand side, we have a product for our exponent. So we can use that rule we used in the previous problem, where let's say we have y raised to the a, and all of that is raised to the b, that when you have an exponent to an exponent, you just multiply. So to apply that rule here, we're just going to essentially go in reverse from the right-hand side to the left. And let me just rewrite the 1/7 to the x. So we want the x to be on the outside so that we can figure out how a relates to this 1/7 here. So let's put this a to the minus 9 on the inside and then raise all of that to the x power. Since notice, we have an exponent to an exponent, so they would multiply to recombine to give us this original expression here. And then from here, since you have 1/7 to the x and a to the minus 9 raised to the x, we know these must be equal to each other. So we can write that 1/7 is equal to a to the minus 9 power. Now, to actually solve for a, we need to essentially cancel out this exponent of minus 9. So we can again use this rule. So if we raise each side of this equation to the minus 1/9 power, we can cancel out this negative 9 as our exponent. Since notice that if we take minus 9 and we multiply by minus 1/9, the negatives cancel. So we just get 9 over 9, which is 1. And so we would just end up with a to the first power here. So we get 1/7 raised to the minus 1/9 power, and this is equal to a to the first power. So we found our a value. It's just 1/7 raised to the minus 1/9 power. So that looks to be choice letter C. And you could double check this. Now you can take this and just plug it back in, and we're essentially raising this to the minus 9x. And an exponent to an exponent, you multiply, so you take minus 1/9 times minus 9, the negatives cancel, and 1/9 times 9 is just 1, so you would get 1/7 raised to the x power.